Good day, students. You're welcome to yet another practical section, CHM192. My name is Dr. Kele Henrietta. I'm here to take you on experiment 3, titled Measurement and Density. I would start with our experiment 3A. The title is Determination of Physical Properties of Compounds. And the aim of practical of this experiment 3A is to determine the density of compounds. Before I go ahead, I would like to talk a little bit on measurements, since the caption of experiment 3 on your course material, CHM192 course material and practical manual, says measurement and density. We know a measurement is defined by a number and a scale of units. The scale used is often varied, but the universal scale, however, used by scientists is the SI unit. Now let's go to our experiment proper, experiment 3A, which is determination of the density of a compound. Here in this experiment, our aim is to determine the density of liquids. We determine the density of 2 liquids, water and ethanol. If you recall, density is defined as mass per unit volume. This is to say that units of both mass and volume are necessary in order to determine density. Density is one way to characterize a substance, that's to identify a substance. For this, our practical will be requiring the following: water and ethanol, and the following apparatus: 100 ml or 250 ml beaker, thermometer, graduated measuring cylinder, and a weighing balance. And for us to execute or carry out this our practical, to determine what we want to do specifically now is to determine the density of water. And we'll go this way following this procedure. Collect about 100 ml of water in a beaker. Let it sit until its temperature is stabilized. Record its temperature. Weigh a clean, dry 10 ml graduated measuring cylinder and record its mass. Now, add water from the beaker to the cylinder so that the level is above 5 ml but below 100 ml, and record the volume accurately to the correct significant figure. Wipe off any water droplets adhering to the outside as well as above of the water level inside. Record the mass of the cylinder with water. Now repeat step 2 to 4 2 more times, each time with a different volume, but still between 5 to 10 ml. You can take volume, say 7 cm cube, 8 cm cube, and starting with say 6 cm cube, 7 cm cube, 8 cm cube. Now you have 3 sets of data. Calculate the average density of water at this temperature. Having known the formula to calculate density, as we said, density is equal to mass of substance over the volume. Equally, calculate the percentage error. The percentage error is given by the expression experimental value minus true value all over true value times 100. So once you know the experimental, the true value, you can calculate the percentage error. So it's as simple as that. to determine the density of a liquid. So as we have determined the density of water, you can apply this principle, this procedure, to the determination of other liquids. Now, from here, we go to our next experiment, experiment 3B. So, our experiment 3B, we'll be looking at the micrometer determination of boiling points of hydrocarbons. That is, we want to look at how to determine the boiling points of hydrocarbons. Before we go further, I'd like to acquaint you with the purpose of this experiment. The purpose of this experiment is for you to become acquainted with procedure in evaluating physical properties such as boiling point and the use of boiling point in identifying liquid, because different liquids have their specific boiling points if they are pure, so you can use it to identify them. Then to determine the boiling points of various organic compounds and use these to identify unknown compounds. To carry out this experiment, we will need the following equipment. So materials, we need a hot plate, a thermometer, closed-end capillary tube, a beaker, small test tube, then our liquid organic compound. The boiling point of a compound is the temperature at which it changes from a liquid to a gas. It's a physical property often used to identify substances or to check the purity of the compound. Boiling point of a liquid is an important physical property. A liquid's boiling point is the temperature at which its vapor pressure is equal to the atmospheric pressure. Like melting points, boiling points are characteristic properties of pure materials. That is to say that pure materials, we can identify them with their boiling points. Once there's an impurity in a liquid substance, it will affect the boiling point. You won't get the exact boiling points, then you know that that substance is not pure. To carry out this experiment, you go by this procedure. Place about 5 ml of the liquid in a small test tube. A capillary tube, see that one end is placed open end down into the liquid. The test tube is firmly attached to a thermometer by means of a rubber band. And this entire assembly, that is the thermometer, the test tube containing the liquid you want to determine its boiling point with the capillary tube in it, fastened to a thermometer, is immersed in a water bath. If it's for a temperature a liquid that the temperature is higher than 100, oil baths would be most appropriate. Then, as the temperature is slowly increased, that's after doing this, you place the beaker on containing what we want, the boiling point we want to determine, on the hot plate. As the temperature is slowly increased, a rapid evolution of bubbles from the end of the tube begins. Continue heating for about 5 to 10 seconds to be sure that all of the air has been expelled from the capillary and the vapors of the liquid remains in the capillary. Remove the heat, but do not take the assembly out of water bath or oil bath. And carefully watch the capillary Bubbles continue to be seen until the pressure exerted by the vapor of the liquid becomes equal to the atmospheric pressure. As the temperature decreases, the bubbles will slow down, and at some point, the liquid will rise into the capillary. The boiling point of the sample is reached when the bubble stops. Then read the thermometer and record the temperature. Okay. The temperature observed when this happens should be the observed boiling point of the liquid. Compare experimental result to the literature value of the boiling point for the liquid used, so that to know if you actually carried out your experiment well. If your technique is good, your experimental value should not differ from the unknown value, that's literature value, by more than 2 to 3 degrees centigrade. So with this, we've come to the end of experiment 3B, that is determination of the boiling point of a liquid. This now takes us to our experiment 3C, which is melting point determination. Boiling point has to do with liquids, then the melting point has to do with solids. In this experiment, our purpose for conducting this experiment is for you to determine the purity of a substance using melting point as physical property, to identify an unknown compound using its melting point, to identify an unknown compound using mixture melting point, then to learn how to obtain an accurate melting point using a melt temp apparatus. The melting point of a solid is defined as the temperature at which the liquid and the solid phases are in equilibrium. In practice, most melting points are determined as capillary melting points, which can be done quickly with a small amount of sample in a capillary tube. A capillary melting point is defined as the temperature range over which a small amount of solid in a thin-walled capillary tube first visibly softens, that's first drop of the liquid, and then completely liquefies. That is, a solid is said to melt sharply if the melting point ranges is 0.5 to 1 degree centigrade. A pure solid will generally melt sharply. If the melting point of a solid is sharp, it gives an indication that the melting point, that the solid is a pure one. An impure solid melts at a lower temperature and over a wider range. Thus, a solid's melting point is useful not only as an aid in identification, but also as an indication of purity. So these are the reasons why it is important to determine melting point of solids in some experimental analysis. The experimental procedure is as follows. Here in this particular experiment, the example we want to use is to determine the melting point of benzoic acid. Benzoic acid is an organic acid. What you do is that you place some quantity of benzoic acid on a Petri dish. and grind it to a fine powder using a spatula. Then use the spatula to push a small amount of the solid into the open end of a capillary tube. Then drop the capillary down several times to fill and pack the sample well to cause the solid to fall to the bottom. Repeat this step until you have accumulated a sample 2 to 4 millimeter high in the bottom of the tube. Okay. To record the melting point range of a compound, feed 2 capillary tubes, each to a depth of 2 to 4 millimeters, with the compound of interest. Here in this experiment, our compound of interest is benzoic acid. First, get a rough idea of the approximate melting points range. Place one of the tubes in the melting apparatus and raise the temperature at a relatively fast rate, about 10 degrees centigrade per minute. Record the range of temperature from the first visible evidence of liquid. The sample appears moist or a tiny drop of liquid is observed. Then, to the complete liquefaction of the sample. What we are saying that you record the range of the temperature from the first visible evidence of liquid, that's when the liquid starts appearing, to the complete liquefaction of the sample. Note the temperature at which the compound first begins to melt. Allow the melting point apparatus to cool to about 20 degrees centigrade below that temperature. And then insert the second tube. Raise the temperature more slowly this time at the rate of about 2 degrees centigrade per minute. Note the temperature at which 1, the first crystals melt, and 2, at which the sample has completely melted. This is the melting point range. Then you take the average. And that gives you the melting point of your solid. Okay. So with this, we have been able to go through the process, the experimental process of how to determine the density of a compound, the boiling point of a liquid, and the melting point of a solid. With that, we have come to the end of our experiment 3.